Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at delegating constructors in C++11. And first I just want to show you something that's kind of only vaguely related in C++98, just to be clear, which is that if we have a superclass here, and here we've got a subclass, then when we've seen before, or we've seen in the free beginners course, that when the child object is constructed, it must run a parent in the superclass, and that's not. It's not because the subclass, the child, is somehow like a parent object and a child object bolted together. It's not like that. It's just that the child object, of course, it includes stuff from the parent class, and you need to run the parent constructors from the child class, and those constructors are not inherited. You can't call them directly, but they do exist nevertheless in the child class, that they're existing to be called. It's as though the child has a slice of it, which is the parent, and then we've added extra stuff onto that slice. So if you define any constructor at all in the parent class, let's just comment out. I've got two constructors here. One takes a string parameter and one takes no parameters. If I comment out this default constructor, because I've defined a constructor that takes a parameter, I've defined a constructor in the parent class, we now lose the implicit default implementation of the no parameter constructor. Child is trying to run that, but it can't, so we now get a compilation error. And this is all stuff that we've kind of seen before. So we have to specify in child which constructor to run. Let's say, well, we've only got one constructor at the moment in the parent class. In the constructor initialization list, we can specify that constructor must be called. So here I'm saying that the default no parameter constructor in the child runs the parent constructor that takes a string parameter. So that works in C++98. I need to alter this one as well. Here I'm constructing a child and a parent object. So if we do this, now this all works and I can run it. So I'm getting two runs of the parent constructor. One because I'm constructing this parent object here, and the other because I construct the child object. Now what's new in C++11, let's just uncomment this, because we can select what constructor we want to use, even if we've got several different constructors. So sometimes it's useful even if the default constructor is present in the superclass. In C++98, what we couldn't do was within one class, so now this has nothing to do with subclasses and superclasses. I just wanted to demonstrate a related concept in C++98. But in C++98, what we couldn't do is we couldn't call one constructor from another within a class. So let's say that in this default constructor, I want to call the string version of the constructor here. C++98 gives us an error with that, but with C++11, it actually works fine. So we can actually do this, and we could have the child. Let's make it call the default implicit constructor of the parent. This works fine. We see this running here. So and this one's also running. So this one here is now calling this one, and that's new in C++11, but it didn't work in C++98, and this is called a delegating constructor. In C++98, a common solution would be to create an init method, which your different constructors could all call if you've got a block of code that you want to call from multiple different constructors. In C++11, we can actually call a constructor from within a constructor. The thing to watch out for is that you don't have recursion, because now I don't want to go ahead and try to call the no parameter constructor from this one, because then they'll go round in a loop, each calling each other, and that's not going to work. So you might want to pick one constructor. I like to pick typically either the no parameter constructor or the constructor that's got the most parameters, and call that from the other constructors if you've got common initialization to do. So we can make this, of course, more C++98 like by using initializing our variables with brackets like this. So we could put that in, get rid of this, and it's a bit of a silly example because there's not enough going on here to really justify what I'm doing, but you can easily see how to use this. So we could use more C++11 type syntax, and also for the child here we could say equals default to get the default constructor there. We can't use equals default here because even if we take out this, we can't use it, because this means it's no longer the implicit constructor. As soon as you're using the constructor initialization list, you've no longer got a default implementation of your constructor, so you can no longer use equals default. This is just an unused variable warning, by the way. Okay, so that's it for this tutorial. Until next time, happy coding.